Alright, somebody. Hello and welcome to a calculus tutorial by Physics Man Education. I'm Physics Man, and in today's tutorial we're going to expand on our last tutorial. In our last tutorial we derived the quadratic formula. Now you may remember that when y equals 0 you have the condition of an x-intercept. Now you can use the quadratic formula to find the x-intercepts of a quadratic function. We found this after some extensive algebra that some of you may not so fondly recall. We can have x is equal to negative b plus or minus the square root of b squared minus 4ac and the whole thing divided by 2a. In general, this can yield two solutions. The first solution is called x1. It's when you take the positive of the plus minus sign. Then x2 is when you take the negative of the plus minus sign. Now this generally gives you two solutions, but remember when we were discussing parabolic shapes in the first tutorial on quadratic functions that you may have two x-intercepts, one x-intercept, or zero x-intercepts. And I think that when you go to apply the quadratic formula here, you will encounter three cases that will help you to differentiate the difference between those three scenarios. Here's the first case I'd like to consider. Let's just say that b squared minus 4ac is greater than 0. It is definitely possible. All we need for this to be true is that b squared is greater than 4 times a times c. Let's consider what that means. If this is greater than 0, that means that it is a positive number, and you're taking here the square roots of a positive number. And the square root of a positive number is a positive number. So that means that when you add your positive number to negative b and then divide by 2a, will give you a solution that is unique or different from when you subtract the positive number from negative b and then divide the entire thing by 2a. So this in general will give you two unique roots, or x-intercepts. Let's draw a picture of what that looks like. What that means is that your parabola has to cross the x-axis twice. Like that. Here's the second condition that you may find. What if you have b squared minus 4 times a times c is equal to 0. This is definitely possible. All we require here is that b squared is equal to 4 times a times c. How will that affect the solutions that we get when we apply our quadratic formula? Well, if b squared minus 4 times a times c is 0, then here we are taking the square root of 0. And the square root of 0 is 0. If you don't believe me, punch it into your calculator. Now, if this entire thing is 0, then minus b plus 0 will be minus b, and then you divide it by 2a. And minus b minus 0 will still be minus b, all divided by 2a, which means that x1 and x2 are not two unique solutions, but rather one solution, because they're both the same. So this means that there is one root. And a quadratic function that has one root will look something like this. It will touch but not cross the x-axis. So it touches at this one point exactly, at the vertex of the parabola, but it won't cross the axis. There's one more condition left unexplored. Well, we've already talked about when this term is positive, and we've talked about when this term is 0. The only condition left is if it's less than 0. When this term is less than 0, that means that it is a negative term. And it's definitely possible to imagine this. All we need is that b squared be less than 4 times a times c. What would this mean when we apply it to our quadratic formula? Well, if this is a negative number, that means that you're taking the square root of a negative number. And you can't classically do that. There are solutions to the square roots of negative numbers. They're called complex numbers or imaginary numbers. And I think we'll be exploring that in either the next tutorial or the tutorial after that. But most calculators can't give you a solution. And the reason they can't give you a solution is because there's no real solution. And the lack of a real solution means that there are 0 roots. So, if you have b squared minus 4ac is less than 0 as a negative number, then here what you're going to try to do is take the square root of a negative number, and your calculator will say, dum-dum, that number doesn't exist. And you'll have a parabola that looks like this. It never even touches the x-axis. And there you go. There's the 3 cases that you may encounter when you go to apply the quadratic formula. I hope that this has been helpful in helping you to understand the nature of parabolas and the roots that they have. This is a production by Physics Man Education, and I'm Physics Man. Thank you very much for watching, and I'll see you in the future.